Hello, welcome to chapter 2, and let's continue. So we created our sphere HDA. Maybe we can dive inside and change this one attribute. We'll go to also only once, but it doesn't matter because our height field is already like 1 point or here 2 points, but basically runs not on every pixel or on not every voxel. It will run just code only. We need it on only once. Okay, save not the type and continue. So let's dive into our terrain pipeline. Our terrain pipeline. And here, geometry import. Because we need to access some parameters. So stream output file, this one, load the geometry during cook, it's okay. Import sphere geometry, we have only one. And here's storage, maybe we don't need the storage, we just need copy from class, or copy all attributes from detail. It means that here the file has some attributes. Here, these detail attributes, and we will copy them, or like we need this one terrain size x count, just x count, epsilon count to copy to work item, because later on we will use them for calculation next item. So here we just need x count epsilon. Here we will create wedge node, and this wedge count, we will specify that this wedge count will be our x count times y count, and because it's attributes, we can specify, or we can just write attribute x count, attribute y count. We don't need access to the geometry inside. Now these attributes live on work items. Here you can see that it creates 72 work items, and as we can see, it's really immediately. And if we just look at our EDG visualization, we can see that for each wedge is totally same, but each wedge item will have different attributes we will use in our next HDA. So let's dive inside, and we can put the file node here. It's to pdg pdg output 0. So it's in, and we can use it in our subnetwork or next HDA. And this one will be terrain split. Maybe then I in the terrain plus init, maybe terrain plus init. So the digital asset terrain files init. Okay. Okay. Maybe say for the false terrain cards init. Okay, great. And here we need one variable. This variable will be our file style pro which is a file. It's not float, it's integer. Apply, accept. Don't need anything specifically. And type inside what we will create. This HDA will create each individual tiles, but each tile need to have some initial masks in it. And this mask we will later use in merging. So first today will be like some height, some full network ends here, and the second terrain, because they will be, each tile will have additional points or additional voxels which will be shared or which will be computed during simulation. Because, for example, after sloping, lerping, or this material can fall down and accumulate here, because this terrain don't have information what is here. If there is like another gap or this again huge mountain. The second terrain again star is so it has some, it has here some, is height, is here that maybe again some hills, hills, and so this simulation or processing this terrain have information that this material need to accumulate, but need to accumulate, for example, here. until here. So after combining the terrain, they need to have exact same height here like here. So we will use the border, we will use both information from both terrains. So our initial mask for the left terrain will start here, use 100%, and here will be 0%. Okay, 1%, 10%, and that will be until the very end. And here, the we'll use this. So at this point, use 100% information from the left train, and at the right, use another color, like this one. Use 100% of the terrain. Okay, so 100% the left terrain, 50% of the left terrain, 50% of the right terrain, right? And again, the border 100% of the right terrain. So these two terrains at this border will combine or will be mixed by both heights, like that. So we need to create this mask, but in 2D. Oh, we will create it. We will create it using box. So here we will I will use tile split node, and example tile we will use. We will use our processor tile. So copy parameter, paste relative reference. So this tile number will be inputted or will be written in work item. Tile count we need to find from the height field because we already know that information. Geometry spreadsheet, we know that the x count or tile count in x is here, so just detail attribute 0 x count index is 0, and here is y count. So we have 26 and split the terrain. Actually, our number processor tile will be like maybe I don't know 15 tile. This one is just uh, mask helper. Our mask we will create box and use that box as projecting geometry to our terrain, and our box will be not typical box. It will be deformed, like the bottom part will be like that, and upper or bottom part will be like that, and upper part will be like that. So it will not be box anymore, it will be like a cone. And information, the height will be specified to 100. So our mask will be 100 or 100% or 1 here, and 0 will be here. So it will be like blue red mask. So we will use maps axis align, alt, use the box, and would align. And scale, not uniform, just X and Z, and group be like only the bottom one, so 3. Translate center, 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 scale to fit, just only X and just only Z. So it's only bottom part. And copy this one here, here, and only second go primitive justify here true. So second up, and we will scale y, here will offset, and here minimum. So it's our mask or geometry we will use for mask. And we can check that it will works if we just keep like the first one. You can see that here the edge is 100 and the mask will be created like in this one region. Second one, left top, right bottom, so it perfectly works. You can put here our test tile, which is 15. Okay, so HF project source geometry to project height farthest replace 100 maximum distance 1000 and now HF I need to wrangle and then our mask is equal height divided by 100 and our height is equal to 0 and that's our mask created. Again, this works for all of our tiles 100%, 0%. Nice. But it will be our output. So it's our first output. So it will be tile which we will be processing. And now we will create the second one where we'll be merging all these individual tiles together. Can be the same size, but I will create it a little bigger so we will, or you can see how it will works to during merging. So let's create HF crop height field crop, and we will use this terrain, so the original one, but we will use this style for cropping. So putting spare input, this one, this, and the size will be like detail -1, size multiply by, I don't know, 5. Copy parameter, static reference. And we need to center it, so we need to properly center it, so we will center it -1 spare input d x x sorry e y e. Okay, so it's like this one terrain, but slightly bigger. We put 1.5, we can maybe 1.2, 1.3. It will be enough. Yeah, it will be enough. It's still like 667. Final thing we need is just I feel like a copy and copy this mask to uh, merge mask. Merge mask and I clear this mask we can clear. So now we have output 0, hide mask, merge mask, and output 1, which is slightly bigger, and is only hide and mask is default. And very last thing we need to do is convert our tile number, which is currently 15, to row position and column position, because the tile number we cannot compare. We don't know which tile number is above us or below us. So to convert it, we can simply use another attribute, wrangle, connect input here and output here. So this detailed attribute will live on our active branch and our passive branch. And the equation or what we will use, our tile number is copy this one here, and the row number will be our tile number divided by y count, and the column number will be tile number tile number modulo y count, and column number will be tile number divided by y count. And row position, row number, attribute column position, column number. We can check it if it's working by function print and f and our dial dial num is I column position equal I row position I, and here tile num and escape new line. It is important. So column position will be home number and row number. Row by row. Oh, yeah. So file number 15 is is second column and third row. You can check it if we just first so column position 0, row position 0, column position 1, row position 0, and so on and on. And the last column position 11, row position 5. So it's counting perfectly. So we can escape. So the split save nodes type and jump into our run pipeline, and here we can use our HDA processor input here HDA here like tiles initialization here, and here we have the processor tile, and we need to build that information from these items. It's very easy because if we can see our each work item has each unique number and is a wedge index. So this is wedge index 0, this is wedge index 71. And we can use that information here. So it will be just like wedge index. And if we will also use our services or generate or created HDI service output files, file geo that we write it, and we will create outputs, and we know that this HDA has two outputs. First is our tile which will be processed during simulation, and the second one will be used later. So we copy here, but we will distinguish or separate the the geometry nodes by tags, so we can filter later on each geometry just this output tag. So now for the left branch we will use tag pro set rain set rain, and here empty rain. It's a tag we can filter on. We will use constructed path like dollar $OS is okay, but not PDG name, but PDG index. Video.sc, and here again PDG index. We see, and here we will not use $OS, but we will use empty rain or empty tiles like that. So let's dirty encode this node, and after some processing already without any problem. Now we can jump in our PDG visualization. We can see that everything is alright, everything is functional. And also because we created two outputs, we can simply check that here. So our work item has two outputs, output 0 and output 1. So that's it for this chapter.